Hello. Rearranging mathematical formulae or equations is such an important skill. It crops up in maths and science exams, particularly physics, and yet many students don't know how to do it. By watching this short video, you'll be able to confidently rearrange formulae or equations like these without relying on those silly formula triangles. Let me give you an example. In physics, we need to know and use many different formulae in order to calculate various quantities such as work, force or distance. We might be able to remember that work done is equal to force times distance, or maybe we're given this formula in the exam question. But what if we're asked to calculate the force or the distance? Would you be able to rearrange the original formula to give force equals work divided by distance, or distance equals work divided by force? Or would you need to rely on something like this? These formula triangles do work, because if you cover up the quantity you want to calculate with your finger, it will show you how to do it. For example, work equals force times distance. Force equals work over distance, and distance equals work over force. But I still think they're not very helpful. Not only do you now need to remember the formula, but also which quantity goes where in the triangle, because it does matter. So by giving you the skills to rearrange equations for yourself, you won't need to rely on the triangles. If we think about an equation such as W equals FD, we might not know the values of W, F or D, but we do know that whatever value W has, it will be the same as the product of F and D multiplied together. That's what the equal sign means. It tells us that whatever's on the left of the equation must be equal to whatever's on the right. We can think of it like a seesaw that's perfectly balanced. Now, if we put something on the seesaw, like a giraffe, we can see that the seesaw becomes unbalanced. That is, until we put another giraffe on the other side, and the seesaw balances back up again. It would seem that we can do whatever we like to a seesaw. We can take things off, or add things on, or move things around, anything. As long as we do exactly the same on the left as we do on the right, the seesaw will stay perfectly balanced. The same applies to equations. We can do whatever we like to them, and as long as we do exactly the same thing to both sides, the two sides will remain equal in value. So, what kind of thing can we do to one of the sides of an equation? We can add things to it, subtract things from it, multiply it by something, divide it by something, we can square it, find the square root of it, or we can invert it. We just need to remember that we must do the same thing to both sides, otherwise the two sides will no longer be equal. So how do we know what to do to an equation? That depends on which variable we're trying to make the subject. This means which variable we're trying to get on its own on one side of the equation. So let's use one of the most tricky equations in the whole of GCSE physics. If we can manage to rearrange this to make V the subject, we should be able to cope with most others that maths or science has to throw at us. Whenever I'm trying to get a particular variable on its own without anything added to it or multiplying it, I like to think of it as an archaeologist would, trying to extract a rare fossil they'd just found. An archaeologist would try to scrape away at the loose bits of rock and soil until they were left with only what they wanted. We need to do the same thing with our maths quantities. To do this, we have to apply the inverse operations. If something is added to our variable, we need to subtract it. If something is multiplying our variable, we need to divide it. Here we can see that the v has been squared, then multiplied by m, and finally divided by 2. In order to remove the 2, the m and the squaring, we have to carry out the inverse of each of these functions in turn. I'll put a list of functions and their inverse functions here, so you can refer to them. So, to remove the divide 2 on the right hand side, we need to multiply by 2. This leaves mv squared on the right. Now, because we've multiplied by 2 on the right hand side, we have to rebalance the equation by multiplying by 2 on the left. This gives us 2e. Next, to remove the m on the right hand side, which is multiplying, we need to divide the right hand side by m. This leaves v squared on the right. Again, the left-hand side needs rebalancing, so we have to divide this side by m as well, which produces 2e over m. Now we need to carry out the inverse of squaring on the right-hand side, which is to square root. This finally leaves v on its own. But now we have to square root the left-hand side, which produces the square root of 2e over m. Finally, we can simply swap the two sides of the seesaw over to give us v as the subject of the formula. If you need to, stop and replay this part of the video so that you fully understand what I've just shown you. Now try these for yourself. Pause the video here and see if you can complete them on your own before I show you the solutions. No, actually pause it here, get a pen and a piece of paper and try them for yourself. So, rearranging each of these equations gives us these solutions. Did you get them correct? Well done if you did. If you didn't, make sure you know where you went wrong. If you need to replay the whole video, please do so. Thanks for watching this short math skills video. You can find plenty more revision materials or advice by visiting plutoniumscience.com or following me on Twitter or Instagram. You can also email me directly or enjoy some of my other videos on YouTube. Keep up the revision and good luck with the exams. Take care.